Trigonometry is a calculating system that enables us to calculate or determine the value of any angle or any side if you're given sufficient information. The first thing that we need to be able to do is to identify and name the sides of the triangle. So these are all based on right angle triangles. These are only sketches, but they're right angle triangles. And let's take this as our angle. I'll call it angle X. Doesn't matter what we call it, but here is the angle. So we need to identify and name the sides. The longest side is always the hypotenuse. And now we know this angle, we can name the other two sides. So with this angle, it touches this side here. So this is next to it, or adjacent. Adjacent. And this one is opposite where the angle is. So this is called opposite. Let's move to this triangle. And if we are given this as our angle, the longest side is always the hypotenuse. This angle now touches this side, so this side is our adjacent. And this side is opposite where the angle is. Often in electrical work, we draw a triangle with a different orientation. If you like, we sort of draw it upside down. So if I gave you this as the angle, then this is adjacent, this is opposite, and as always, the longest side is the hypotenuse. So that's important that we identify and name the sides before we start. When we're going to do some calculations using trig, you're going to need to know the three formulae that we're going to use, and there is a memory aid to help you with that. So let me just write one of the formula out. So the sine of the angle X, if we refer to this, the sine of the angle X can be calculated from opposite over hypotenuse. So we need to remember this one. We also need to remember a formula for cosine and another formula for tangent. And what we tend to do is we can summarize this into a little memory aid. And it puts all three formulae, sine, cosine and tangent, and all of the combinations of the sides that we need in one little memory aid. So you may remember this one, so, ka, toa, SOHCAHTOA. What we have is sine, cosine and tan, and then for each one there is a formula. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. There are many other memory aids around, and the most common one that we encounter at the moment is sex on hard concrete always hurts, try other alternatives. So whenever you're going to do some calculations using trigonometry, I would expect to see you scribbling this or something very similar somewhere on your page adjacent to where you're going to do your calculations. Let's do a few examples. So in example 1, part A says find the length of the opposite side. Well, let's label up the triangle. Here is the angle. This side is going to be next to it or adjacent, and this side is going to be opposite. We already have the hypotenuse is 20. So how do we proceed from here if we want to calculate the length of this? first of all, scribble your little memory aid. Socotoa. So these give us the three formulae that we're going to use. And we have an angle and we have the hypotenuse. This is important. We need to identify what you know, that's those two things, and what you want to find out. And this is mostly about the sides. So we know the hypotenuse and we want to find the opposite. So we choose the formula, sine, cosine or tangent, that has h and o in it. And there's h and o. So the one that we want to use is sine. Let me explain how that works. So it comes back to the angle, and we would write the sine of the angle we know equals opposite over hypotenuse. So opposite over hypotenuse. If we use our calculator to take the sine of 15 degrees, take it to 4 decimal places, and that comes to 0.2588. 4 decimal places gives you reasonable accuracy. And that equals opposite over, and the hypotenuse is 20. So this may have looked complicated, but all I've done is I've taken the sine of 15, I have a number, opposite is what we're looking for, and hypotenuse, we have another number. So we've just substituted the numbers we know. At this point, we transpose and take the 20 up to this side. So it becomes 20 times 0.2588. So 20 times 0.2588 is the opposite. So our opposite equals 5.18. And that's it. Okay, let's have a look at example B. I've just crept a little bit too low there, but it doesn't matter. Let's have a look at example B. In example B, you're asked to find the adjacent side. So here is our triangle. This is hypotenuse. The longest one is always the hypotenuse. This side touches the angle that we're given, which makes this adjacent. So use our memory aid that we've got at the top, and we want the formula that links what you know with what you want to find. So it's A and H. And if you look at this, cosine is A over H. And we will write cosine of the angle is adjacent over hypotenuse. Excuse me. At this point, we can take the numbers. Cos 15, 4 decimal places, 0.9659 equals A over 20. So once again, to find A, we're going to transpose this and bring the 20 up to here to multiply. 20 times 0.9659 equals the adjacent. So our adjacent side is 19.39. Done. Let's have a look at example 2. In example 2, one of the sides is 300 long and we have an angle. Label up the triangle. The long side is your hypotenuse. This side, which touches the angle, is adjacent, and that one is opposite. So the question says, find the length of the hypotenuse. So we want to find H, and we know A. Always look at what you know, what you want to find. And then use your memory aid, and we need the formula that links A and H. And once again, it's this one. Cosine is A over H. So we will write cos 20 degrees is adjacent over hypotenuse. Let's put the numbers in. Cos 20 degrees, using your calculator, 0.9396, go to 4 decimal places. A is 300 and H is what we're trying to find. So we can transpose this. We want the H to go to the top line, and then this will go back underneath. So the next line will read H equals 300 over 0.9396. Put that in your calculator, and the hypotenuse is 309.4. Quick check, the hypotenuse is the longest side, and it's longer than this one here. So we know that we're probably in the right area. Okay, so let's move on and do a very different example. In the previous examples, we've been given one angle on one side, and we find another side. In this example, I've changed the orientation of the triangle. We do that quite a bit in electrical work, but it doesn't matter. It's still a straightforward right angle triangle. The hypotenuse is 10. And here is the angle we're using, which makes this side the adjacent. And the question asks you to find this angle. So we're going to use the memory aid. So 6 on hard concrete always hurts. Try other alternatives. So those are our 3 formulae. And we have A and H. Those are the 2 bits of information we've got, A and H. From that, using cosine, we can find this angle. And it's going to go something like this. Cosine, I've called the angle phi, so cosine of phi is adjacent over hypotenuse. If we put some numbers in, cos phi is adjacent is 8, the hypotenuse is 10, that comes to 0.8. So the cosine of our angle is 0.8. So that's fine, but this isn't the angle. You now need to use on your calculator the cos to the minus 1. So where you have 3 buttons, sine, cos, tan, you have to press shift because above each one is sine to the minus 1, cos to the minus 1, and tan to the minus 1. And that will take us back to give us the angle. So let's write that right now. We've got cos phi is 0.8, phi is cos to the minus 1, 0.8. So if you do the key sequence, cos to the minus 1, 0.8, and you hit equals, you will hopefully come up with 36.9 degrees. And that is the angle phi.